Hello, Diego. Rob.
Hello. So are you with us?
Hello, do you hear me?
Yeah.
Okay,
I hope you can hear me as well, right, Mil?
good. So yeah,
Okay. Trying to listen on untitled folder. 2, 3, and I don't know if I don't know if I have stopped listening to you, hearing you. Is there any problem? Looks like.
I digo, I can listen to you, but no others.
Can somebody try and speak to see if that makes any difference?
I can hear.
Ah, fine. I think I can hear.
Now it seems I can hear you because it was total silence for a while.
Yeah, I was getting errors from it, but I don't know why. So sorry for the
Okay.
delay. Right, let's get going. It's a bit late. Okay, so we lost a few minutes, so we'll try and catch up. So we'll whiz through these first slides fairly quickly. So welcome everyone to this virtual interim meeting. This we're going to focus on data models today, but we're going to have a few updates with some other things as well. So just going to skip through these fairly fast. So this is the note well. I hope that everyone has had a chance to read this. Looking down the list, I think most people have quite experienced IETF. So if you're not familiar with the note well, please go and look at it offline. But given we're running short of time, I'm going to skip over it. The note really well. Basically, let's be polite and kind to each other in terms of how we engage. I think everyone in terms of the meetings is doing that. So let's continue in that vein. That would be nice. Right, on to the agenda today. So the plan is to have a 10-minute intro, which I've used up most of the time to sort out audio issues. Then the plan is to do some quick updates on existing drafts and discussions based on the last interim. So I think Benoit's going to talk about the framework for energy efficient management and give an update on that. A quick update on use cases or check on use cases and terminology. So that's 15 minutes there. The bulk of it's like an hour to discuss data models. Chin and Chen Zhen, I think Chen Zhen's presenting some data models there on those drafts. I've got some sort of questions on data model structure. Really, that's just to try and drive discussion. So I'll just put those throwing those together fairly quickly. And then we've got half an hour for discussion. So I'll try and go through my questions fairly quickly and things. But it's just an idea basically to spur discussion. And then something that Diego and I have been thinking about is potentially whether we want to try and form a design team to drive the data model discussion forward, or whether, so basically we'll get feedback as to whether that's a sort of good choice of how we do that. And then finally, we've got some future planning wrap up, and Louis is going to talk about doing a hackathon at the next IETF meeting. So is there any agenda bashing on this agenda at all? People are happy with what's been proposed here? I see none. And probably I'll skip over this one. So a reminder what's out of scope of green really, but we're focused on energy efficiency, both reporting and configuring data models, and the work that goes with that. And out of scope is like environmental sustainability and carbon accounting and other stuff that could come into scope in future, but it's not in the scope of what's there today. So I think that's going to cover my chair slides. Oh, I should say we'll be capturing notes. I'll get that sorted in a moment. We'll put a link to the notepad in the chat. If you can all help try and capture notes, that will be good. Both Diego and I will try and capture them as we're going as well. Had I initialized the chat, the notes or not yet, Diego? If not, I'll do that before.
I have started to write. The point is that I cannot. I was going to directly copy the markdown agenda, but apparently that the data tracker, when I try to when I try to see the markdown sources, shows me in HTML. I'm trying, but I'm trying to follow it. I will change the format later on. Don't worry.
I can do it. I've got the raw markdown, so I can do that in a few minutes. So so basically, Benoit, I think it's over to you to. Have you got slides? Ask to share screen. Yes. How do I say yes to that? Can you just put that share request in again? How do I approve that? There's ask to share screen. How do I prove that? Benoit, can you give me a clue as to how
I think if you select the user and you right click or something on the user, I think there might be something to give
pass slide
permission.
control, user management. Oops, no. No, that's not it.
Over my name, no? On the right-hand side?
Yeah, I can't see anything that says pass slide control. Is that it?
All right.
That might be it. It says a new deck is being shared. Is that yours? Sorry about that.
Oh, no, apparently it needs to have my slides loaded, so I sent them not so long ago. I've got the slide control.
I have passed control to you again, Benoit, because apparently.
Okay.
So you should be able to show it right now.
Yes, but it tells me to select from the list of loaded slides.
So the chairs might have to reprocess the loaded slides if you just posted them, or
I send that to the green chair, Diego.
yeah, you probably have to upload them, and you probably have to click on the button somewhere under settings that gets you the right reprocess.
Okay. Do you want me just to present them from my?
Sure.
Does that work? From start. Oops.
So while you're doing that, maybe I'll do the intro, if that works for you.
Yeah.
To save time. So this is the work we've been doing with Louis from Telefonica, Jan from Foreco, Marisol from Cisco, Emil from Orange, and Vucin from Huawei. This is the framework for energy management. We arrived to the version 3. The draft is called draft-BellMQ, which is like all of the first letter of the name. So BellMQ Green Framework. So then I would need to have the next diagram.
Yeah, I'm still trying to get this because it's I'm struggling now to not get it in presenter view. You just have to carry on talking, Benoit. I will upload and try a different way.
Okay. So what we did last time is that we took a figure from the BOF, where we had 3 different levels. And you could see this picture if you go into the draft. And I'm going to cut and paste the draft link directly into the chat. Okay, just take me. All right, so draft link copy to the chat, and if you go there, in the first picture that you will see, there is 3 levels. At the top, we've got the network domain level. Number 2, the controller, which is the collection, compute aggregation, and at the bottom, we've got the device and the component. It could be a device itself, it could be a component, it could be a legacy device, which is that I've got no monitoring for even power or energy, or it could be an attached device, a PoE camera, a PoE phone, a smart PDU, something like that. Or so there are 3 important interfaces. The first one is the interface, which is inventory capability. The second one, this is the monitoring. This is E. And the third one, this is the control. So why is it important? Whenever we look at the framework, the first thing we're asking ourselves is, does the device we monitor, does it support monitoring? And if yes, then maybe it's perfect. Maybe this is the monitor. If you go to the next slide, maybe it supports monitoring for itself, like a device at the bottom, the 1 in Roman numbers. Or maybe it supports the monitoring of something else. That's like a sensor. Then after that, we go into the control. It supports control, right? The interface F here. And then we need to understand that if it supports control for itself or for someone else. So if you go on the next slides, and you would see always the top right-hand side from the previous interim, So here we had the notion of energy object. In this case, a physical meter at the bottom is in the middle of the topology of the power supply and the legacy device. So we had to define the notion of the energy object. And in this case, the controller must know that the energy object 1 is actually metering for the legacy device. This is something that the controller must know, whether we put it manually or not. So we discussed that last time. On the next slide, this is a physical meter with a newer device. So let's say now that the previous object 2 was replaced with a new one. It's consumed less, so that's better. So in this case, the object 2, which is the Y at the bottom there, maybe there is a way to also meter its own consumption. So now it means that maybe we don't need the physical meter X. But in this case, what's happening is we might be doing double counting, because the physical meters for the device component Y. So that's why we must have the notion of the metering relationship, X meters for Y. We discussed that in the last meeting. On the next slide, we arrived to an example of the power over Ethernet. And when Lewis will be discussing about the smart PDU in the hackathon, it's the same thing. We've got like a device on the left and a device on the right. In this case, with PoE, we've got a device switch, and at specific port Y there, which in our terminology is called power outlet, we've got like a device connected. And a device could be, let's say, a PoE camera or PoE phone. So it means that we need to have the power source relationship, that if I set the port X, it's going to give power to Y. So this is what we discussed last time. You see at the top right hand side, it's always from the previous interim. So now if you go to the next slide, this is the same example with a smart PDU composed of multiple ports that are controlling the power given to multiple servers in a rack or switch or whatever. Okay, on the next slide, what we discussed is the notion of inventory capability, which is not well defined, because how do I know that from the controller point of view, I'm able to understand which capabilities I have on my device? It could be on, off, or it could be some with intermediate states in between. How do I know this at the network domain level as well? So this one, it's still something which is not well defined. Now, on the next slide, this is what we've been covering as a difference. We put a clear definition for the power source relationship, and I invite you to just review this on this call, or maybe over the mailing list, which is even better. So we've got the power source relationship at the top and the metering relationship at the bottom, which is something that the controller should know at some point in time if we want to do the monitoring or if we want to do the control. And then on the following slide, what is new is that we introduced the notion of the power state set. And as you see, it's just a screenshot from the diff. So a power state is an attribute, okay, let me repeat this. It describes a condition or node of a device or a component. So whether we call that power state or energy saving, in my mind, is the same thing. The semantic is to specify the functionality provided by an energy object or a limitation of the power of that energy object. I want the fan to run at 50% of its energy, or a combination of the two. So the last series of bullet points means it could be an absolute power value. It could be a percentage. I want it to go in percentage of 10%, whatever it means. or indication of power relative to another power states. So I wrote to be completed because if we go to the next slides, this is where I believe that we are. So there are some there are different views on the mailing list. Now, do we want more than just one on-off? Some of us are thinking, you know what? I just want to know if that device, that line card, that component, that interface, that whatever, has the ability to reduce some energy consumption. And if this is the case, great. We stop here if we only need to have on-off, which means that the controller should know everything about that. Now, if the question is, sometimes there is more than on-off. You can go to hibernate, or you could go to sleep, or you could go to minimum efficiency of a component. Then what do we have to do? There are two solutions there. The first one is that we try to find a finite number of states or value of energy savings. These are the same thing. But then we need to rank them relatively. And the issue will be that what does it mean to go to power states or energy saving X if I'm on vendor blah, line card blah blah, and software blah blah blah. So this is the difficulty, this is the inventory. But it means that if you need more than on-off, maybe we have to go in a direction. Or we say we take a range because everything is relative. If you want to save energy, I guess that if it's called energy saving, if I say 50%, it's better than saving 25%. So I believe this is maybe a discussion to be driven by the chair and maybe later in their agenda. But before completing the next steps in the framework, I believe you will have to solve those issues. And this is where I'm going to stop.
Okay, does anyone else want to join the queue and ask any questions now? So definitely we'll cover this later in the discussion. In some of the questions I've been framing and things like that, I've had exactly the same questions. In fact, I've used some of these sort of very similar examples to this. I think for me, the key question is that understanding it in terms of components. I think that's going to be the tricky thing. In terms of this document progressing that, I think that hopefully the data models and the framework will progress in parallel and such that we don't have to answer the framework question first. We just have to know that we have to get to an answer before we can complete that work and complete that document effectively. So I think these two things can go in parallel. I'm just going to go back a couple of slides to the one about relationships here. So I just had a quick comment on here, or this one on the previous slide, in terms of, for me, I think it's important to be able to capture these relationships, but I'm hoping that in the mainline case, we can sort of hide that complexity so you don't see the complexity and it only turns up when you need it. So I'm hoping it doesn't sort of pervade through and you always have this complexity between who's reporting the data and where it's coming from. Is that if it can degenerate into the mainline case, it's like actually the device is reporting its own power or energy consumption. I think that is better. So that's the first comment I have. And then the second one related to this does the same issue exist both at the devices and devices publishing the data and at the controller level, at the network level? Or is it the fact that when you get to a network level, you can normalize this and say, well, actually, at that stage, you're only looking at the power attributed to devices, even if it hasn't been collected directly from the device. It's been reported by someone else.
Okay, two good questions about the hiding. So I believe that the state of the industry is still that people would like to do the monitoring, right? So if you go back one slide, please. Actually, keep that one, the number 6, it's even better. So the number 6, as you're going to see in the hackathon, we've got a smart PDU there. And the smart PDU, you're able to meter anything on device component 1, device component 2, device component N. Great. Now, if the use case is to provide how much is my network actually consuming as a whole, right? We could be hiding the relationship, but the key issue in this case is if I have the ability on device component 1 to also retrieve the energy, I need to hide this somewhere above the controller, right? So it means that somehow in the controller, I must know that if I take at the same time, if I do the sum of the energy or power on the port of the smart PDU, and I also sum the one from device and component 1, because typically the logic is that if I want to have the full consumption of my network, I do the sum of
Just
everything.
Yes.
But in this case, you could be hiding this to report, but somehow the logic must know that you must not be doing the sum of those two. Otherwise, you're going to double count the consumption. So hiding, it depends at which level we want to hide it. In the report, I agree we should hide it.
Yep. Okay. I think it's yes. I think it's this aggregation layer. Fine. Okay. Diego, you.
Yeah. Just a comment that I assume that that we are considering, or you are considering, controllers as energy objects. I mean, that you can have as many levels of recursion as they are required. I mean, a controller can be informing other controllers, that can be aggregating and hiding or whatever. I assume that's the case. I mean, that's...
It is the case. Now we make a distinction between something that you set for yourself. Let's say that you are a router and I could be setting to you, you're going to optimize your fan from now on. Or you're going to optimize, I don't know, your optics from now on. This is an optimization that you do on yourself. This is like the on-off, agreed. And you do your best over there. And there is the other one where you are a PoE camera. And I'm going to set the switch to shut down the power to you, right? So I need, again, I can be hiding the fact that I have to set not yourself as the PoE camera, but a different object there. So not sure if I'm answering your question about the inheritance and the recursive. Yes, you could have multiple of those, but in the end, we have to go one step at a time.
Sure. No, that's and that's part of this morning talking about the open questions as well. How you build how you aggregate and you build the aggregates is something that is quite an interesting question that I assume it is still open.
And on that front, something that I have not mentioned because I only had 10 minutes, there's a third relationship. If you look in the diff of the draft, you will be seeing an aggregation relationship, because maybe you have a sensor and the sensor is actually aggregating for 3 different things behind it. So I don't want to introduce this. I'm hoping, as Rob said, that the Yang models are going to evolve at the same time. And one day someone will say, I need to have that use case. But, you know, I didn't want to, as someone mentioned, run before I walk.
Okay. I'm just thinking of the time. Should we move on? Because we can cover this later on in the discussion as well. Oh, Jan, did you want to ask a quick question?
Yeah, I'll try to be brief then. I mean, few people will want to look at the detail of these graphs and trees here, but it needs to be auditable. We need to have a possibility to make an audit. So then it must be possible to find all this out. And also at these graphs here, it looks like it's always the whole component, the whole device that we're interested in. But I think, if all you wanted to know is how much your data center or colo is drawing, you can just look at the utility bill. So it must be some reason why you want to break this down further. And that is probably because you want to assign this to customers or use cases or projects or something like that. So this customer X is using so much. And then you need to be able to see which devices or maybe which functions within the device that particular customer is using. So we need to break this down in many ways.
Okay, let's move on.
Thank you.
Okay. So I don't know. So next up, I've got a slot for a quick giving an update on the framework and use cases. I haven't heard of any updates to use cases documents. So hopefully we'll have an update for the next meeting, because I think would be nice to get that adopted and actually within the working group. So I haven't seen any update for this. The authors of one of the terminology documents have requested working group adoption, but only in the last day or so. Diego and I have only briefly discussed this, but we will probably defer that sort of discussion and to happen around IETF 123 and see from there if there's enough interest. So, but it would be good for people to review those terminology documents with that in mind. Okay, so I think next up we're into the sort of discussions, the main part of the meeting in terms of discussing data models. So Jen Cheng, can I call on you to present? Let me just share the slides.
Yeah, sure. Thank you.
Hopefully I've got the right ones. And if I pass control to you, does that work?
Pass control.
You should have control of the slides.
Yeah, it works. Okay, so hello everyone. I will present this young data models for energy efficiency management on behalf of the authors team. Okay, so first let's have some recalls on the chapters of Green WG on this young model topic. So we'll be developing young models to enable measuring and reporting of energy usage through metrics and attributes at component, device, and network levels. And also, we're providing young models to allow operators to optimize energy usage in network components, devices, and across the network via configurable energy efficiency capabilities. And also on the deliverables, there's a description of definitions of young data models as a component level, device level, and network level for energy efficient network management. Okay. And so here, Benoit just mentioned this architecture moments before, so I will not repeat the components of this architecture, but still we could check with the models here. So we may have three kind of models. One is network inventory management data model. And another one is network level energy efficiency management data model. So these two models, they lie on the northbound of the controller. So we can see this them here as a network level. And the third one could be energy efficiency management device level. So it's on the northbound of a device, and we can see it here. And also there's some recollections of the relevant young data model work we have been done up to now. So firstly, it's the draft CWBGP Green Energy Saving Management, and it's split it into three, each focusing on specific use case. The first one is called Green Common Energy Management, and it's meant to be reused by various energy efficiency related modules. And what's been defined here, there are features, identities, types, and groupings. And second one that's been split it into is green inventory energy management. So here we have the energy efficiency capability exposure for each network element there. and we have those temperatures and voltage threshold rated power for the component. So these are all inventory related. And thirdly, we have this green topology energy management. So here we define all the dynamic energy consumption metrics, both as a network and device level. And beyond this, we all know there's the draft Lee green power contribution from Tony. So it's about a device level power management. And there's also some issues being discussed in the GitHub. So we would like to suggest that for energy saving model design, we could have this three part. So firstly, with the common part, we could name it energy efficiency common. And for network inventory energy saving, it could import the common part from this common module, and then it could augment the network inventory here. And then we could have this network level energy saving model. It could also import the common part from here and then augment the network model of RFC A345. And here we have some more concrete view of this common energy model. So first, for the feature, it indicates whether we support this energy saving feature or not. And for identities, we have this energy saving mode with basic, standard, and deep options. And for energy saving method, we have such as and use the high-speed interface shutdown, and use the port shutdown, and use the board shutdown, etc. And for energy saving power state, we have off state and full power state, and all the interim states between, such as sleep, low power, etc. And for type, we have power on and power off for energy saving. And for groupings, we could have this energy consumption data. So there will be real-time fluctuating power, voltage, and temperatures. And also for the groupings of energy saving modes, there could be a list for energy saving modes and methods. And for power parameters, so we could have operational thresholds related to temperature and voltage, and also rated power, etc. And for groupings of energy power consumption states, we could have, like comprehensive energy consumption and energy efficiency ratio or rating. So there's have been some some open issues on GitHub right now. One of them is power state with energy saving mode. So for energy saving mode, it's related to basic, standard, and deep. And for power states, it's this. So there are some connections, but for energy saving mode, it's also related to performance and reliability requirements. So we could set different levels of energy savings. With a deep level, we could save more energy than standard level and basic level. I think if needed, we can discuss this a bit later in the discussion period. And Also, there's an open issue on is energy saving model applied to both a network element level and network level. So basically, we think that both green inventory energy management model and the green topology energy management model, they are a network level model. So we could also use a device level model as well. And for next steps, we're requesting the WG adoption call on the common energy efficiency module. Could it be served as a common module building block for various young models? And is the current definition sufficient or a good starting point? And at the same time, we would like to continue to align this young data model with the terminology document. And of course, we're happy to address all the issue tickets raised on the GitHub. Okay, so that's all for these slides. Thank you.
So any questions from anyone now? I mean, there's time for further discussion in a minute, but is there any specific questions here? I was just going to comment on the adoption call. I think this is probably slightly preemptive. I think at the moment we want to try and get to a point where we're sure that everyone is aligned on the right direction here. So I think it's good to keep progressing these modules and discussing them. We'll have further discussion related to that later. Like if we do design team, then that might be a solution here. But I don't think we're quite at that stage yet, because I know there's some sort of differences of opinion on how these things are modeled. Otherwise, if there's no other further questions on this slide set now, I will present the slides on some open questions, and then we'll move directly into sort of discussion. Okay, so thank you, Jen. So these are just some questions that Diego and I have thrown together as I was sort of thinking about these. Some of these I've put on the A-list, and I'm not sure all of them. Let me just set a timer so I can keep in mind what I'm talking about. And these just meant to drive some like ideas and discussion, and these are some of the things I think we need to solve. I don't think we necessarily need to solve all of these now. And I think in terms of the later discussions we'll have about trying to get the core data model working and getting that structured. But I think these are things that we need to consider. And some of these overlap with what Benoit's presented. Now I'm just going to go over each of one of these in turn. Feel free to ask questions or comment on these now, or make notes, and then we can come back and discuss these further later. So first of all, what level of dependence do we have or should models have on the framework? So I think this is one of the issues or questions I have in my head, is that do these data models have to be tied to the framework in terms of how they're structured, either through groupings or the structure of how the data models are structured, both on the device or the network level? Or is it somewhat independent of the framework, and the framework's just supporting how you fetch these together? Or is it sort of beneficial between the two in terms of how they're aligned? Or does it not matter? So, Benoit, have you got thoughts on this? Yeah, chip in now. That's great.
Right. So, first of all, I don't believe that we should run this in sequence, having a framework, then young models, or vice versa. This is a given to me. However, there are a couple of things we're discussing in a chat about the UUIDs, right? Yeah. And why do we discuss this? Because we know that at some point in time we need to have those relationships. So there are a couple of basic things that we must agree early on in the Yang module. Like the UUID, for example, will be the same UUID as the one used in Ivy. And it doesn't mean that we need to augment Ivy, but this is like a key, I wanted to say key, yang key, on which we must be focusing. And if we get it wrong day one, it's going to be difficult. Then at the same time, whenever we're going to discuss, do we need more an on-off? It could wait a little bit, right? But whenever you get that answer, because we know it's going to be required, then the Yang module must adapt to that. So it's not like in sequence, but if we get the wrong building block in the Yang modules, that's going to be very difficult. That's my point.
Okay. Jan?
Yeah, I agree with Benoit that we should not build them in sequence. I definitely think we should be supporting devices that are already out in the field today that will not be aligned to anything we ever come up with here, because they're out there and we need to live with reality. And we can't wait until the 15 years it takes to get this all out there. But it doesn't. That said, if for devices that actually want to contribute well, there are fundamental concepts like, for example, this we talked about UUID, for example, or maybe certain measurements. For example, the definition that there's a concept of a client or a customer that we want to distinguish, and that needs to be reflected in those more capable devices. Then, so for basic support, no connection, but for higher level support, at least concepts need to be aligned.
Right. Emil.
Yeah, just to add that I think we need a central place where the capabilities are described, and avoid to have the capabilities to be described in different documents.
Okay, can you
clarify?
Yeah, I was going to do the same.
So, Emil, can you clarify
what do you mean when you refer to capabilities, Emil?
Well, okay, sorry. So the capabilities with regard to monitoring and with regard to control and so on.
Oh, yeah, okay. So, but that wouldn't be that part of the common model as well?
Yeah.
I mean, identifying those capabilities?
Yeah, I think, yeah.
Okay. Fine. Okay. I'm going to move on to the next. Ben, are you back in the queue or are you still in the queue from before? Okay, I'm fine. Right. Okay. So, and everyone, please feel to chime into these discussions. So, on to the next one I had. So this one, I think Chin's or Jen Chen's slides sort of drove this, is what layer of relationship between the models do we need? I think it's fairly clear to me, I might be wrong on this, that we need to have some level of data model for devices and components, certainly ones that are exporting the data. That's an obvious one. And again, having some network level model in terms of as an abstraction, again, is like an obvious choice if we need those. I noticed that in Jen Chen's slides, he had both like topology and inventory models. And those both sort of fit at the network layer, I think. I wasn't quite sure whether we need both of those, possibly, potentially. I can see that maybe inventory one is reporting, or augmentation onto inventory is reporting raw data, whereas topology one, I guess, gives you the option to report it at for a given customer or something on a network topology. So, so I get a question for that. And but also this question is, do we need to do anything higher layer than this in terms of being able to report it to end users, where those end users could even be customers, or they might be other operators that need to then consume that data? Or is the network and the topology level or the network level model sufficient for that? Is there a high level layer one that needs to be designed there? Luis.
Yes. In my view, yeah, I would be in favor of defining as well a kind of service model, so that we can identify what could be the energy that could be somehow allocated to one specific service. This will help us as well to consolidate the views across the different domains. So basically identifying per flow or whatever it means that we could identify so far how to do that association. That basically we want to report to the customer what is the let's say the impact of their actions. We need as well to have this kind of service model.
And there is a choice there that we're making a conscious choice of the modeling that in Yang is the right choice, because again, I haven't been following onions that closely, but I know that there's been some discussion about generating OpenAPI, Swagger APIs from the Yang models. But again, I guess having a customer-based Yang model allows you to generate those OpenAPI definitions. So maybe that makes sense.
I would say that the immediate way to work on that would be Yang, and maybe later on we could consider the APIs and so, yes.
Okay. Diego?
Yeah, no, I wanted to, this is something that discussing some time ago with Ting about this, it's about the terms that are being used here, because it looks like, to me, looks like what we're doing, that we should distinguish between at least 3 or 4, if we take into account what Luis was saying, 4 different levels. One is at the so to say, device or component level. This is which is something that is what can be measured for a particular physical element. Then there is this is what has been called inventory, that I think is a little bit misleading, because probably if you're talking about what the capabilities Emil was referring to, then we would have inventory. Then we have aggregated, what is has been called topology. I mean, an aggregated can be aggregated because you have several devices connected on a particular topology, or simply because you are adding the consumption of different elements that are being fed by a single device, as Benoit was showing before. And with these 3 plus the one that Luis was mentioning, what is about sort of an end-to-end, well, an end-to-end or a service-wise. Let's not say end-to-end, service-wise. Aggregate. That would be enough. So we were talking about 4 different levels. One is of the information of capabilities that can be associated with inventory. Second is on the individual energy object. Third is an aggregate of these for a particular network configuration, and 4 is that from the service view. I would try to avoid calling things regarding to topology, because just topology or inventory, because they don't have a clear relationship here, in my view, and probably can be a little bit misleading.
I think I raised them here because that's how the sort of data models have been designed. In terms of one of them is talking about augmentations to topology and inventory. I think that's a question there that we need to have and raise. I'm just looking at the time actually, and looking how far through I am these slides. So I'm going to try and go a little bit quicker. We can carry on with these questions as we go, or again, I can cover them at high level and then discuss afterwards. So, so this one, Benoit's raised this. I'm also raising how much granularity in power control do we need? So I'm saying this could be generic states like reuse EMAN's work, or a range. Again, Benoit suggested this should be very simple on off. Should this, and the key ones I think is, should this vary by the components being modeled? I.e., do we try and cover a single abstract thing, or do we have to say actually the power states for a line card versus a forwarding ASIC versus the fabric versus a port or a optics, they're different. And hence we should be trying to tailor the data model to allow more granular settings for these different things. So I think that's something that in my mind is probably quite important to discuss. I can see the benefits of a generic thing, but I can also see how sort of tailoring these to particular components may give a more usable data model. And then the last one I had on this is, does the configuration align with the operational state, as in be able to report the current power modes and things? Do you then align the configuration to be able to set those? And I'm not sure you do. I think what you can report might be quite different from what you can configure and set and control. Let me just try and zip through these and we'll come back. And then another key one I've been thinking about is, does the control relate to intent or the actual power usage? So are you saying I want to put the device into sleep mode or hybrid sleep mode or cold sleep mode right now, or for a given interface or port or line card? Or are you saying I want to put this device into sleep capable mode or hybrid sleep capable mode, and then you're leaving the device to decide? So I think we need to be very careful here about lots of devices that will do their own power management automatically and some level of control, versus maybe some of the things that I think Tony's interested in is saying, actually, no, a controller knows better, and I want to control the state directly of particular components or different parts of devices. So again, I think that's an important thing we need to model, an important question we need to come to. I'll skip over the next bit. Question 5 is, again, I sort of raises about how generically do we treat these for models and components and things? Do we do it very generically or specifically? And a comment I've sort of made in the latest previously is, if we use identities, you can have a coarse level of identities at the top level and then use augmentation such that you can derive more refined identities to both report more information and potentially allow more refinement in terms of what can be controlled and configured. So that might be something where we can leverage Yang for this. So interesting. Question 6, how do we report power for other devices? Ben has already raised this. So again, I won't cover it now, but I think this is an important issue that's fundamental to the models is how do we do that, and how does that differ between what's done at the device at the network level? I.e., it might be you have different levels of complexity there that's necessary. A part of it might be the aggregation of taking data off the devices that allows you to simplify it when you are storing to the network level, and obviously how to avoid double accounting. So that's standard. I won't cover that one again. Diego raised this one of how do we do the aggregation. I think that's important to understand, both like at the device level and the network level. And how do we allow data to be reported in aggregate if we want to do that, and also in a fine-grained way, but without the double accounting issue. So again, I think that's an interesting question that we need to come to in terms of the structure of these models. Got 2 more. I was just out of time. Again, this is another of Diego, is how do we report the accuracy or the granularity that's being reported in the data model? Is that statically defined, or does a device need to be able to report what accuracy given information is being reported at? And my concern here is that if you push it into the data model for devices to report it, A, you have to trust them, and B, it adds a lot more data and complexity into the data model. Whereas if it's defined statically, then again, that limits you. If the device can't report at the granularity that you are defining the data model, then you're limited. And I don't think that Yang deviations really help you here. So again, that's another key question in my mind. And the last one was time intervals. Is the data being reported over? So if you're aggregating power over time rather than just reporting instantaneous power usage, again, who controls what those intervals are? Is it devices that are choosing those time intervals? Are they predefined? Are they fixed? Do we have some standard set of time intervals that devices can be reported at? If each device can choose what time intervals it's reporting its power usage at, again, that makes some of the aggregation more complex. Right, so that's the questions. Summarizing that now. Now we've got basically half an hour, 35 minutes, like open floor discussion of these things. So be good to either join the queue and either discuss these specific questions and comments on here, or other ones you want to raise and discuss. So does anyone want to kick that off, please? Or if you think that, yeah, Jan, go ahead.
Yeah, I think it's an excellent list of questions. So I think that's a very good start to do this. I don't know exactly which one we should dive into first, maybe number 4 or 3.
Okay.
Can you
go back to, yeah.
Yeah, so in my mind as a controller guy, very much interested in having a generic API towards all devices, basically, for controlling their power. I don't want to know if it's a router or an interface or a video coding engine or something like that. But I would like to be able to control this across customers. So one customer is at higher power save and another one at lower. And I would like to know what the trade is. So if I tell a device, hey, if you can go as low as you can on the following conditions, that you can get back to normal in 500 milliseconds, that throughput is at least 50%, and the latency is at most 40 milliseconds. Go to as low as you can for this customer with those parameters. That's the sort of interface I'd like.
And for me, that's the key question here. Is so when you say to a device, I want, like for ours, you say, I want to put you into energy saving mode to use 50% power, less power. It's like, well, what does that actually mean? Because if that's like, I want you to reduce the forwarding plane by half power, fine, you can do that. But most of these devices, yeah.
I'm not talking about telling the device to reduce power to a specific power level. I'm just saying, go to as low power you can, provided that you keep these other conditions. The throughput must be at least 50% of the usual. The latency at most this much, and you should be able to return to full power within 500 milliseconds. Do what you can with those parameters, because that is from my customer agreements. I can derive those values, and I'll tell you, go do your best with these conditions.
And I think it's that condition is the key one. Is like, how quickly can you come back? So actually, the one saying you need to be able to come back to full capacity within 500 milliseconds or 10 seconds or 2 minutes, that then allows the device to choose exactly how it does power saving. Okay, Benoit? Yeah, go on.
So somehow it's what I was trying to express, I believe, on the mailing list, is that going to energy saving or power modes or power states without talking about SLA is actually not terribly useful. Like exactly what you two described. I want do your best at the condition that this line card will come up within 1 second, or that it will not lose more than that. I will not limit the data plane to more than 50%. So somehow this is the difficulty here. This is what we have to do, and this is also the difficulty in documenting those power states. Because if I document the power states, we have to decide, okay, how am I going to read or discover the power states? And there is not a single way to say this, telling do your best under condition X and Y. Because maybe another power state will be do your best under condition X, Y, and Z. So as a consequence, I believe that whether we use a range or a series of power states, it is all relative. And it means that there is almost no way to put the capabilities of those power states in a formal language, like Yang even, because it's always linked to an SLA and with some variables, some attributes, and some values. I hope I was clear.
I think so, but again, I struggle then to say if you define this generically. So either through a set of power states or given values, I can understand, like you could say, I want to run a fabric at 50% capacity. I can understand how you say, I want the forwarding plane to run at 50% capacity. I struggle to understand how you say, I want the optics to run at 50% capacity, because they will use as much power as they need to maintain a stable connection. And you can't really modify it in that way. And so I think, again, in terms of the SLA agreements, how long it takes will depend on whether it's something internal to the device or it has a network-wide impact in terms of protocols having to reconverge and things like that. So I think that's the bit where I struggle with these generic definitions, is I sort of feel you're going to need to say, this is the settings for generic ones for fabric or forwarding plane or optics, etc.
You just ruined my point that not everything applies to every component type, etc. So the only thing you could be doing is something kind of relative for that component.
And I think the data model needs to identify those components and maybe have different data fields for those components, is what I'm thinking. So Emil?
Yeah, responding to Benoit, actually, I don't know what he means by the SLA here. Is it a grid SLA or a IP network SLA?
It's not IPSLA networks, but whenever you say to a network component, do your best, what does it mean? It's that do your best, but don't drop packets. Do your best be in standby mode, but actually don't lose packets. So it means that you must be up and running in 0 seconds or something else. So it's not the IPSLA one. This is the SLA for the network to come back where it was before.
Because, yeah, but from the power view, we may have SLA too. As an example, when you have a shortage in power, you want to optimize the duration of the battery. And I think that in this working group is the power aspect came with an additional network, which is a grid. And in the case of shortage, it's something that is crucial to be clearly present in the data model. And I don't know how. I don't know if it's binary or not, but the component or the blade must have a signal saying that you are in shortage situation, so you have to reduce your power consumption, and you may be cut in perhaps 10 minutes, 1 hour, something like that.
So you're right. So if I take my PC and I'm on battery, maybe I need to say, I want you to last as long as possible. Obviously, I will have reduced capacity of my PC, right? And I'm just telling it's important to know this.
So I was just giving a slightly different answer to Emil. So I was just imagining that if you have got particular like TE traffic engineering services configured over your network and you have a primary and backup path, you've got choices as to how quickly you expect that backup path to be restored. Does it is it expected to be restored immediately with no traffic loss, or would you accept a 2-second outage or something, or 5-second outage if you went to that backup path, if you're willing to accept that therefore you're using less power because you don't have to have everything running hot standby. You can have other things where actually different links are sort of powered down and you need to bring them back up within some period of time.
So I think there are many use cases and policy for that. We don't have all of them. If it's a run, you may want to decrease, its power because you want to double the duration of the autonomy of the run. If it's a router in the center of a town, you may speculate on the fact that the power will come again in less than 15 minutes. But it's something that we must clearly reflect in the data model.
Diego, do you want comments?
We don't hear you.
I muted because apparently I was making too much sound, too much noise with my caffeine. Sorry for that. My point is that I was wondering whether, as part of the of the design team work, we can end up with let's say a list of a few, and when talking a few, probably no more than 6, 8 potential states that could be roughly defined in terms of, for example, optimize traffic efficiency, like bandwidth or whatever, over power consumption, optimize power consumption over everything, reduce power consumption to without lowering a minimum set of metrics in terms of traffic, things like that we could define in general terms, not, I mean, for sure, not characterizing. We cannot fully characterize everything for every single potential technology, but at least we could identify a number of general patterns that could be identified and then refined or augmented by the device manufacturers, and in some cases clarified when you're talking about apply a policy of power consumption a power saving under any circumstance is something that can be clarified what policy means. So what I'm advocating is for a few, identifying a few let's say typical patterns in connection with the general SLAs. I don't know. I mean, probably that would be the most we can think of in terms of characterizing somehow and allowing and leaving the rest for augmentations or even the direct device manufacturer interpretation.
Emil?
Yeah, so can we try to agree on that? I mean, is resiliency a state with regard to the power delivered to the components? I mean, when a device go in shortage of power, does it make sense to have the device to tell to its components, we are in shortage? So this is the situation, and so be ready to face to shortage too, because we are working on battery now.
So I was just going to chip in. I think that's a great question, Emil. So I think that's a question I hadn't considered, was whether the work we're doing here applies equally to battery powered devices or devices that are connected, that are powered. I guess that is an obvious use case we should consider here. So yeah, I think it's
I mean that resiliency is an important you see SLA with regard to the power. And if we want to make a data model for power efficiency, it's not only the reduction of the power consumption. You see, it's how to do the best usage of the energy we have. I will not insist on it, but perhaps we can summarize it like that.
But I'm just going to jump in the queue again because no one else is. But for me, I think for most devices, like even like a Mac's better than Windows in this regard. The Mac is either the settings for power control on my laptop is very minimal. It's like, do you want maximum power? Do you want to be maximum energy saving, or do you want somewhere in between, like a 3 modes? And that's sort of it that it gives you. Windows, however, gives you a lot more settings you can control. Do you want to limit your CPU to 100% usage or 50% usage? What's the minimum max? It gives more flexibility, but I'm not sure how much people need that or care about it. And ultimately, it's really about whether you just need to optimize it or not. And even then, when it comes to routers that are plugged into the wall and serving off connected power, then as far as I understand, they should try and be as efficient as they can, use the minimum amount of power to serve the sort of forwarding that they need to do. So it's sort of, I'm not sure how much you need settings. First, to say I want you to perform in high performance or power saving mode, I'm not sure our devices, lots of them, might not make any difference for that. So I think that's another consideration. Diego, have you got a question or comment on this? No, I can't hear you. We can't hear you.
Oh no, I had some issues with my audio. That's it, and I click on the raise hand by error. Sorry.
Okay, so so we saw a little bit more time to discuss these before we discuss. Is there other questions? I mean, anyone got any more comments? Still on question 3. Is there any other questions people think we should tackle here that are more important? Now's your chance to control the direction of conversation. Benoit.
I would like to address the number 7, right? Because it was briefly mentioned by Diego. So, and that comes back to the notion of topology. So there is the physical networking topology. There is the power topology. There is actually a monitoring topology. A sensor is monitoring on behalf of the next device down the power line. There is a control topology, but there is also the aggregation. So if I take a line card, maybe you will have the power consumption for the entire line card, but you have also the power consumption for each of the ports of the line card. Just an example, right? But it means that if you don't know that the value on the line card is somehow the sum, the aggregation of all the things on the line cards, including something that you could be monitoring independently, then you are doomed with the simple use case of representing how much power energy is used by your network. So that's why I introduced in the charter this notion, in the framework draft, the notion of aggregation relationship. So that's something that you will need to have, not everywhere. So Diego, you mentioned a level of recursion. Obviously, if you know that the line card reports on everything on the line card, including, the ASIC on which you could be monitoring, including the port that you could be monitoring, that's enough to say line card, our report is for everything. Now, if you arrive at the controller and you're monitoring every single thing you can, you must still have that notion. Otherwise, you're double counting again. And maybe I should have a figure like this in the framework.
And yeah, that might be helpful. I think in my head, the question then becomes is does the framework or the data models always try and solve that generically? Or is it done in a data model specific way where if you've got a data model that says this is the power usage of the line card and this is the power usage of the ports, it says very clearly, or maybe it reports both for the line card. It's like this is the power that the line card CPU is using and the split outs, and also this is the aggregate power, as in you do it at the data model by having separate fields. But then the complexity is you're tying it more to the structure of the hardware and tying it more that the controller software that's aggregating this data together needs to understand those fields and need to understand exactly which ones are returning aggregate data versus which ones are not. Or you assuming it'd be done generically?
So what do we have in Yang to help with that? We've got an English description. Can we trust?
Correct.
Can we trust that the line card, we say this is the total used by the entire line card? If you trust that, we're good. And if the device is compliant with that, you're good. What is the alternative? The alternative is that we've got UUIDs for every single component. And we know that we're using the same UUID if you do an inventory, if you do a CMAP, if you do green. And then if you have the relationships there, then you're on the safe side. It comes back to the argument from Jan. Is this auditable? Or you just trust the description in the Yang module?
But even then you have the same consideration. So I sort of agree with you a bit, but you have the same consideration that ultimately the value that reporting for the line card could include the aggregate of all the devices on there, or it could choose not to. And so either way, somebody's got to read that and do the right thing, because there's always different values they could put in. They might just put in the power usage of the CPU complex if they're not thinking about it, or they might. So I'm not sure it solves it.
So somehow you read my mind. How do we audit this? And just relying on a Yang description might not be sufficient. And yes, it had complexity. As I mentioned, in the world of green, we don't have a single topology. We have multiple topologies: monitor, control, aggregation, and power. And if we don't take this into account, or if we don't quantify this very precisely in the Yang module, we will not be able to solve all the use cases.
So that I agree with. I think that we have to be, and that's where the framework can help.
I think that it's true that we need this kind of knowledge about the different topologies that are being used for measurement. But at the end, when it comes to trust, the only way of getting trust on these, I'd say, is precisely by the process of certification of the user. I mean, user, when talking about users, I'm talking about the the network service provider. This is something that if you wanted to make a traceable and auditable, etc., the only way that at the end you as the one who is going to be responsible of deploying a particular device or set of devices on the network, that you make your independent measurement and check whether your measurements match with the measurements that you're making and that you are being reported by the different modules. That's normally the certification process that we follow for other features of a device, whether it fulfills a particular protocol implementation, or it provides the required capabilities. And at the end, it will be a matter of running this evaluation at the lab, and something that will be required, as in many other cases. This would add only an additional dimension. But on the other hand, I believe that I agree with Benoit that informing when you're aggregating, informing how you are aggregating, what has been the process of aggregation, and which is the process of the way in which energy is fed into the different elements is important, definitely.
Benoit, any more comments on this? You're still in the queue. So looking at the time, I think that we need to somehow have a lot more discussion on this. I think that this is a good stage to move the next phase of our discussion, which is how we sort of progress these going forward. So we'll do that. And then if there's time, we'll come back to have further discussion here. So let me stop sharing this and move to next. So, okay. So Diego and I had a discussion a couple of weeks ago, actually, about whether it'd be helpful to try and have a design team discussion or design team set up to sort of come up with base level Yang models. So I think that I'd like to quickly present on our idea here, then try and get some feedback from the working group as to whether they think this is a good direction or not. And then again, I've got some proposal here in terms of what we would set the scope for that design team to do as to whether that's useful. So I'll just quickly go over these slides. Let me just set a timer for myself so I know how much time we've got. This user interface is not great. So I only got a few slides, but I'm hoping there'll be some discussion on this. So we're considering a data model design team specifically. So what we're thinking of is to charter or task a design team to produce initial data models for the green charter items, covering both the measuring and reporting side of it, and also the data models to do control and influence of those things, because we think that those two things go hand in hand. And to be clear, is the proposal here is not that the design team would have to come up with a complete solution, but we're really tasking them with trying to get that structure sorted out and agreed. And the questions, which not necessarily my set of questions before, there might be other ones. Those might be some of those might be too complex or not worth discussing now. But understanding what the list of things is trying to be addressed and making sure that those core constraints are addressed, similar to how Benoit says, look, we need to be able to cover these use cases, and hence we need to have a design like this. But again, I know that I think Tony, for example, well, they've been very quiet today, Tony, has been saying that actually there's a different approach and we're trying to simplify that. So I think it'd be good to try and find a way to have those discussions on a more frequent basis. Now, one choice we can have is to have these interim meetings. They're currently like a month apart. We could have them a bit more frequently. But I think it'd be useful to get a stage where these issues and discussions that people can meet on a regular cadence, maybe on a weekly basis, to try and thrash out these issues in a more informal way and make progress and get consensus, and then come back to the working group and say, look, we've collectively come up with a proposal for how we think this should work. So that's what we're thinking about. In terms of what we're tasking it to, this is the scope that we're considering. I've emphasized in bold a couple of these particular things. So again, to define simple Yang models offering a base energy data model. It could be one or more drafts, we don't care. And I've got it here, so covering component, device, and network level. If we thought that, or if the design team said, no, we actually needed to also to cover, for example, inventory topology or like service level models, again, that's fine, that's okay. It doesn't have to be just those things. We define what's in scope. And associated with that would be to define any common groupings or any metrics or terms that are specifically used by those models. So it's not proposed that this design team scope is to come up with new metrics or come up with new terms, but if there was ones that came out of the modeling effort, then that's fine. Those could be added in. And we've left it open as to how much the framework document should influence this. So it doesn't have to be, we're saying that there's no requirement that this must conform to a specific framework draft. If there's good reasons for it not to do so, but equally it could and maybe should take into account a framework document, that's fine. We've left that one open. And to be clear here, we're not proposing that this design team has to get fully complete models. In fact, I think we will be pushing for trying to get like a base model structure done and agreed, so that then it could be augmented out if appropriate with extra capabilities and functionality as needed. So that's the aim. So that's the proposed design team scope. If we go down this path, we're open to feedback from the working group. So the two key questions are, is having a design team helpful? As in, do you think this would be a good way to progress with our specific goal of trying to get some data models adopted, some base core ones in the shorter term, rather than having lots of discussion before we get anywhere? And if you do think that's useful, do you agree with the scope or have any comments on what we're scoping here? So what I propose is we open the queue is already open for comments and people to comment on this. I might do a poll of hands as well to see if people think this is a good direction. And to be clear, is if we did a design team, we would probably try and choose half a dozen, 6 or 8 people across the different drafts and things, different authors, to try and get together and thrash out the issues and hopefully come up with a sort of common approach. And the last thing it's worth saying, for those that are not that familiar with design teams, it's not a fait accompli that whatever design team comes up with, that is what the working group would adopt. You'd have to go through the standard adoption process, and other folks are allowed to submit competing alternatives and different solutions. However, the desire is that by doing a design team and hopefully getting the different parties involved, that what's presented is representing some sort of level of consensus between at least the people who are involved in discussions. So opening the mic up for comments or questions, thoughts. Marisol.
Yep, I have a comment, and thank you, Rob, for proposing this. I agree, it will be good to have a design team, but I want to add, because it has been several attempts to put YAM data models for it, right? You know, I was part of this PowerF proposal, where I think is a good base, honestly. But independent of that, because there are several proposals already on the table, I think it will be good to bring this up and, you know, have this design team to decide what to pick up from each, because everyone has been going through some thoughts already, and we don't need to start from scratch. Just considering what we have been putting, you know, probably Power started with the OPSA, then we moved to Ivy, same for other drafts, but I think we should consider, you know, that we have already something to start with.
So just to make it clear is it's definitely not the case that we say the design team has to start from scratch at all. That's fine. They can reuse, leverage existing work. They can collectively decide actually they think one particular draft or design is the right way of starting. But the thought is there are different competing solutions, by getting the folks in a room in a more informal setting of having the discussion is maybe that it's easier to get to that collective consensus as to what a good starting point is. It might be that the design team fails and actually that's not possible, that the folks can't agree and we had to find a different approach. But the question is, we think that might be a reasonable way. And just looking at the chat from Jan's comments here about discussing the questions is highly relevant as well. Well, again, those questions and maybe others, the design team would be tasked with sort of considering those and putting those into design discussion. If the design team felt that you need to have wider discussion, have interims to cover those questions and get some more thoughts on that, that would also be fine. But the thoughts I think Diego and I are having is like, even get a focus group to focus on this and make progress in a smaller setting and then report back to the working group, that may be effective. Benoit.
So actually, I wanted to share something along the lines that Jan shared and what you just mentioned. So I was thinking, how can we have an efficient design team? So if we were doing in a design team the same discussion that we have here, except that we've got people with only the strong opinions because they've been writing the drafts, I'm wondering if this is actually useful. When I look at the series of questions that you had, and those were pretty good, I'm thinking, if we could address a couple of them already, then a design team would be sent in one direction. And to answer those questions, I believe that you need the consensus of the entire working group. Otherwise, I believe that all of the authors, and I'm not an author of the Yang module, right? But I could see the different divergence. And I believe that we're going to work, discuss. And in the end, we would need to resolve at least 2 or 3 questions from your list of questions. And if we're in agreement on this, you have the better scope than just telling you guys, go in the playground and organize yourself.
So just to paraphrase or summarize, Ben, let's check I understand what you're saying is, I think you're suggesting that it'd be better to have some more interim meetings to focus on those questions with the chairs leading those discussions or helping those discussions forward to solve some of those key questions first, and also have the discussions on the lay list as well. And then at that stage, then you think that a design team would have more likelihood of success. Yes. Is that fair?
This is a first statement. Or you get the design team and you say, you know what, in a month, we must have those 2 questions resolved. You have the interim, you put design team at the same time. It could be done in parallel, right? But just having design team discussing those 10 questions, it's like, I'm not sure it's going to be successful. Thanks.
Okay.
That's something that we were discussing this morning, and I do believe that we need to keep in the after IETF 1 to 3, we will need to keep in parallel design team meetings so we can advance and have proposals to be shared with the group, and in parallel, at the same time, probably 1 week it will be design team, or the other week would be a general interim call or 2 meetings of the design team plus and 1 interim call in which precisely the decisions and the answers to the open questions that the design team comes up to can be shared with the community and agreed. I mean, it's not to freeze any interaction with the community till the design team has totally finished and shows something as a fait accompli. But the idea would be to make it dynamically.
I missed your. Can you update the notes? But there you go. So, I was just what I suggest at the moment is that we do a poll of hands or show of hands, and I might ask 3 options. One is do we have more interim meetings? 2 is do we have a design team? And I think the 3rd option is, do we as chairs try and drive discussion on those specific questions on the ALIS? And we can do a combination of those 3. But I do note at the moment that the conversations on the ALIS, there's only a few people that sort of jump into those conversations. And even again on these meetings, again, there's a sort of smaller set of people voices we're hearing. Diego, just give me a thumbs up if those questions sound okay. Right, so I will just ask those. Okay, so my first one is about design team, and I've said here, should we try and arrange a design team either now or in a few months' time? So again, if you think that this isn't quite the right time, that's fine. And obviously, the couple of people are voting no here. You know that I'm going to ask you to comment either in the chat or come to the mic, preferably, just to indicate what your objection is, because that'd be good for us to understand if you're willing to do that. Tony?
So I feel that Michael has a valid point. The group is pretty small. We can just meet more regularly and more frequently, and I accomplish the same thing.
Okay, that's fine. And that's valid comment. Okay. So there's one other no. Was that Michael, or because you've expressed that comment on there, but I don't know otherwise. But don't feel free. You don't have to come back. You maybe comment on
Not me.
Not
I
you.
have
No. Okay, fine. Okay, so there's still quite strong support for doing design team. But so the next question are going to be is should we try and arrange more frequent interim meetings? I would say, I'd say every 2 weeks. I'm not sure we should go for every week, but and it would be at the same time. And it may be actually we do so more frequent meetings, say every 2 weeks, but again we could poll and do it on a weekly basis. I think if we were to do that, we'd try and make the interims a little bit less formal in their nature in terms of being prepared to needing to prepare slides, and we try and focus those meetings on specific issues and discussions. So again, there's quite a lot of quite keen to do more frequent meetings, and again, there's one person saying no here. Are you willing to indicate why? Oh, Rashad.
Yeah, so I mean that was just based on the assumption that there would be okay design team. So I'm not against having more frequent interim meetings, but if there is a design team, having interim meetings every 2 weeks seems overkill. Every month or once or twice between IETF meetings would be what I think would be good.
Yeah, absolutely. So I think that's definitely fair, that if we were to do a design team, then it would end up that they would have more frequent meetings and they would have less frequent interims of them reporting back. Okay, fine. That's a good one. And the last question I was going to ask is, should the chairs try and drive discussion closure on specific questions? Key questions. On the list. So the question here is really whether you want us to try and drive this discussion on the list. Obviously, IETF does like list email discussion, but if we're not going to get enough discussion and attraction and people prefer to discuss these in person, I think that's more effective, then please vote no. If you think that we should do them on the list or we should do them in parallel, then please vote yes. I'm not. Maybe my question's not clear here. Okay, so that's more mixed. We've got some yeses and some no opinions. I'm sort of assuming the no opinions are if we can have this discussion in person and that works effectively, we don't need it on the list. But doing it on the list is also fine. So maybe we'll try and do those in parallel somewhat. Okay, so I think that is useful for Diego and I to go back and have a think about how we progress this in terms of how we do next steps and things like that. Obviously, we will have we're meeting in like a month's time in Spain. So again, there's more opportunity to for us to sort of discuss and update next steps and to have further discussion there. So we've got 2 sessions there. So I think we've got some indication there. Thank you. So time-wise, we're still doing okay. We've left a bit of time, and maybe we have some time at the end to go back. I think at this stage, I can't remember. Was it Neil? Did you have I think you had a presentation quickly to give on a hackathon. So I think now would be a good time to give that. And then we can go back at the end if
that was Luis, yes.
Oh, Luis, sorry.
Yep.
I was looking at the names, I got it wrong. Apologies.
Problem. Yeah, I can be very brief on this as well.
No, you can spending 10 minutes is fine.
Okay. So, well, yeah, the idea, the purpose here is to socialize the activity for the hackathon that we are trying to move forward. So I will explain more or less where we are now and what could be the next steps. So for keeping the working group informed, and for sure we can inform as well in the mailing list. So we took the opportunity of the interim just for this first advertisement. Next, please.
That's all right. I can give you slide control. That helps.
Okay.
Okay, you've now got slide control.
Okay, perfect. Thank you. So just to be sure, okay, in the second one, yeah. So the basic approach that we follow for the hackathon is to try to exercise some of the use cases, but for sure we will not face the use case entirely. So basically, what we will do are activities that somehow relate with the use cases that you can see highlighted in the slide. So the application of the green framework to some extent, for sure. So also to the collection of energy information from cloud native network functions or virtualized environments, and so also the consideration of end-to-end metrics, including metrics that could come from other domains. All of this probably will become more clear as long as we advance in the presentation. Also something related with the video streaming use case, where we will have some video streaming capabilities there that from where we will be able to collect energy metrics. The management of the energy efficiency network management. So basically understanding what is the overall consumption, and for that maybe derive some kind of management action, hopefully. And the fact of the double accounting. So the point that we could be retrieving from different systems energy that is consumed by a device, so that we could somehow work on the direction of avoiding the double counting on the consumption. So I will move forward. So the goals for the framework is essentially to exercise the notion of the framework. Probably we can exercise partially that notion, maybe only concentrating on the observability, because at the end we don't have probably now the means of acting on top of the network for doing that optimization, or doing that management of the energy efficiency. But at least the idea of collecting the information, retrieving the information, aggregating them, and produce this observability. Let's see if we can go further on top of that, and probably perform any other, let's say, part of the framework in terms of action, manageability, and so on and so forth. We will work with these different use cases, as I mentioned before. With the video streaming, we would like to demonstrate the possibility of identifying the consumption per flow. So this goes in relation with my previous comment about the JAM model for at service level, let's say, so that we could identify what is the energy that could be consumed or allocated to a consumer across different domains: the video streaming domain, the network domain, the device domain, the terminal domain, and so on and so forth. For instance, in the case of the double counting, we will leverage on smart PDUs that are collecting information directly from the devices, and basically trying to compare the information from the device, from the PDU, and trying to visualize, let's say, the possibility of double accounting in some situations. And there are other goals that are being defined now so far. We will bring as well some wireless access point for measuring the energy in the wireless access, and so on and so forth. So this is somehow open, and we will clarify as long as we have clear what can be done there. So I will show you now part of what could be the setup. This will be an idea of the setup for the streaming case. This is coming from the European funded project Exigence. And essentially here what we have is a streaming setup. We have the injection of different films, let's say, with different codecs, and those codecs consuming different levels of energy. So we can exercise that, create the streaming flow, and understanding what is the energy that is being consumed by the streaming head end at that point. So when injecting the flow. So that would be one part of the setup. You can see as well there are some wireless access points. And for that, and you can see here in the PDU, also there are a number of physical meters of the energy. So yeah, the idea is to collect the information from the virtual environment with the video head end, let's say, but also the physical part from the smart PDU, and try to reconcile the data and view the data. Here at the front of the slide, you can see some Grafana like graph. So the idea is to collect all this information and integrate this information with information that we could collect from network devices, as I will show you in the next slides. So other part of the setup will be the capabilities that we have in Telefonica Labs. Our initial idea was to bring this kind of smart PDUs, as you can see on the left of the picture. But we have a dependency of what could be the physical setup in the hackathon room. We need these kind of connectors that you can see on the middle. So probably not feasible to bring physically the smart PDU to the room, but we can always allow the VPN access to the Telefonica Lab, so that we can consume the data that this smart PDU is collecting. I will show you later on, but I can advance that these kind of smart PDUs are collecting information from a number of servers, a number of routers, so different kind of devices in the lab. So the idea is for us to make available the system that we have for collecting the information, and also the APIs of these smart PDUs, APIs or SNMP. I will comment with later on that. So basically to access to the smart PDU to collect the information. I will move forward just to explain a little bit more on this. So we have this Schneider smart PDUs that can connect different kind of devices. This is what we are using for that. And these PDUs offer access through SNMP and APIs. We have worked with both APIs and SNMP. The data is the same, but there was a problem with the stability of the API some time ago. So this is why we also exercise the SNMP, but even probably it's not too much appealing to talk about the SNMP these days. This is that kind of dashboard that we are producing in our lab. So based on the metering of these smart PDUs, probably it's too small, but you could see here in the list number of devices that we are monitoring from different vendors: ADVA, Cisco, Huawei, Juniper, Nokia, and so on and so far. So the idea would be at least allow the access to the some of the smart PDUs, so that information can be retrieved in real time if finally we are not able to bring physically the smart PDU to the hackathon room. Well, basically, this is the explanation of this. This is a development that we have done internally to Telefonica. Also, we are working to making this available as open source for the hackathon, but we need to follow some administrative stuff in Telefonica for making it available, but hopefully we will have for the time of the hackathon. And this is the kind of system that we have. So with different open source tools like Telegraph, InfluxDB, and Grafana. But that said, the very minimum would be maybe to allow, you can see on the left of the slide, allow the retrieval of the information from the smart PDU through the SNMP or the APIs that these PDUs offer. All the integration of that, at least in the Telefonica lab, also has interaction with the inventory that here is represented by the Netbox tool. So in the network tool, we declare all the devices that we have connected to the smart PDU, and because of that, we can correlate the information and then present in the same way that I showed you before with that dashboard. So apart from all of this, well, let me say that apart from all of that, also we are working with other participants of the hackathon on bringing more stuff. It's not yet decided, but we will advertise in the wiki. And just a kind of summary or idea, or basically with what we have shown before, we will try to exercise part of the framework as we have mentioned before. This inventory, for instance, in the interaction with the networks, is a very toy inventory, but somehow we showcase the proof of concept on that. Monitoring the devices, monitoring the information that we collect from the devices, and these devices could be directly routers or could be PDUs and so on so far, and trying to aggregate everything. Also, remember that idea of the video content, so also collecting information from other domains, even though those other domains could not be directly connected, but this is just a way of showcasing the aggregation of information. And the very last slide about next steps. We are now, Marisol, working in the registration of the activity in the Hackathon Wiki, so should be there already. We are finalizing the discussion on what to provide to the Hackathon room in terms of devices, equipment, scenarios, and so additional stuff will be provided as mentioned. And basically, we need to complete the description on the Hackathon Wiki, and be sure that we will advertise properly in the mailing list as well, so that whoever is interested could participate and could join the effort. He or she will be very welcome on this. And that's all from my side, Rob. Thank you.
I think that sounds great. We've still got a few minutes. If anyone's got any questions or comments on this, Louise, can I ask you also to send an email to the Green Working Group list highlighting the fact that you're doing it? I don't think you have done yet, but that would be good to do. And obviously people know to reach out to you if they're interested in participating in this. Would be good. But I think it's great to do this. It's always great doing.
Sure, we will do. Yeah, for sure.
Any questions or comments? Okay, no, so that's good. Thank you. Just sharing. So I've got no more slides to share. So I think that's been just to sort of wrap up today's session. I think we've made some good progress on discussing some of the issues. It's fairly clear to me that there's some key issues that we need to drive to conclusion. So we've had some more discussion, but I don't think we've necessarily reached any conclusions anywhere. You've given us some good input feedback on how we try and sort of accelerate this and progress this further forward. So Diego and I will discuss that and sort of figure out how to move forward a bit more. But otherwise, we've got no more interims before IETF 1, 2, 3. So we're looking forward to that coming up. We've got in hopefully 2 sessions booked, 3 hours in total the preliminary agenda comes out at the end of this week, so we'll find out how that's been allocated, and then we'll be thinking about how we allocate that time. If you want to present, then please let us know. Now's a good time to be thinking about that on any of these things and updates to the drafts. It'd be good to try and get a framework adopted. It'd be sort of good to try and get some sort of terminology adopted, but however, I still think it's important both to progress the data models, and so I think some of the key questions are coming from the data models. So I think I'd like to defer progressing the data models as well. So we'll spend some time on that as well. So I think that's everything. I've got any last comments from anyone else? Otherwise, I might give you back a few more minutes at the end. Diego.
Just a note that Rashad was, I replied to him on the chat about the requests, what the ISG requests for the design team, and I think that we have followed all that requirements, and for sure there will be a very terse scope, and that will be declared. And as I said before, the idea is to coordinate. Michael and Tony are right that the group is small enough to allow for a direct coordination between the group and the design team, but having the design team help us in address the so many potential based models that we have on the table. That is the number that is that the design team, I hope will allow us in picking the best part of all of them and start addressing these open questions that we were discussing before in parallel, trying to maximize consensus and efficiency. That's all.
I think one of the key concerns, or one of the things I heard, is whether that design team will be able to self-organize and get consensus of whether they need some moderators in tomorrow's discussion to drive it forward. So that's a key one. But I think that's everything. So I thank everyone for their time today, and people who put slides together and presented. That's good. Thank everyone else for the discussion and commentary. So I think we've had another good productive meeting. We need more of these. We need more chat and discussion on the mailing list as well. So try and sort of get some forward momentum here. But so thank you everyone for the time, and look forward to seeing you all in Madrid if you can make it. So.
Yep. Take care. I'm prepared for the temperatures in Madrid. That's.
Well, my room is 30 degrees here, so I'm preparing.
This week, Madrid is above 35 centigrade. Just for you to know.
Okay. The Romanian is 30.
We're going to train. See you.
Exactly. Go to the sauna. Take care.
Thanks, everyone.